Hey guys, and welcome to my next tutorial. In this series, I'll be covering React Query, the best data fetching library I've used so far. Before we go through how React Query works, it's important to discuss what problems React Query solves. Let's discuss a common scenario. If you're building a React application, at some point or another, you'll need to communicate with a backend server. You'll likely want to be fetching data, as well as updating some form of data. As an example, take a simple to-do application, where you can fetch a list of to-dos, create a new to-do item, and complete the to-do item. All of this is server state, because the source of truth is our backend database, not the front-end React client application. Even though React is a very flexible framework, it does not have an opinionated way of fetching data. You might start brainstorming and think of approaches such as useState or useEffect, and other hooks from React. Now, this would be a valid approach, but in a larger application, things can get complicated quite fast. Let's complicate this even further and ask ourselves some more questions. What about separation between client and server state? What about caching? How do we update out-of-date data in the background? How do we even know when data is out of date? What about managing memory and garbage collection of server state? And so on. While all of this would be possible with your own solution, React Query can help us with out-of-the-box solutions. As described by the official documentation, React Query makes fetching, caching, synchronizing, and updating server state in your web applications a breeze. So now that we have an understanding of the problems React Query aims to solve, let's go through some of the core concepts of the library. To have a good grasp of React Query, there are three core concepts you'll need to understand: queries, mutations, and query invalidation. Let's go through each one. First, we can discuss queries. The definition found from the official docs is the following. A query is a declarative dependency on an asynchronous source of data that is tied to a unique key. In simple terms, what this means is a query can be used to fetch data from a server. A simple example would be making a GET request to retrieve a list of to-do items. Let's see what this looks like. To subscribe to a query in your React component, all you need to do is call the useQuery hook. You'll see here that we provide the hook with two things. One is a unique key, and also a function to retrieve the data. The unique key you provide is very important because it is used internally for refetching, caching, and sharing your queries throughout your application. Let's expand this example to see how it can be used in a React component. What's important to note here is that React Query keeps track of loading and error states for us, so we can easily render a loading message or an error message. You'll see in the code snippet we check if status is equal to loading, or then we render a loading message. Otherwise, if status is equal to error, we render an error message. And if none of those conditions match, then we know we're in a success state and we can actually render the data. Next up, let's talk about mutations. So unlike queries, mutations are typically used to create, update, delete data, or perform server-side effects. So just to reiterate, a query is used to get, fetch data, while a mutation is used to create, update, or delete data. Let's see how this works in a React application. First, we call the useMutation hook and pass in a function. In this specific example, we pass a function to create a new to-do item. And then we call the mutate function in the onClick handler of the button. And that's really all it takes to include a mutation in your component. The third core concept to discuss is query invalidation. So the official docs outline query invalidation as the following. Usually when a mutation in your app succeeds, it's very likely that there are related queries in your application that need to be invalidated and possibly refetched to account for the new changes from your mutation. So a simple example is that when we create a new to-do item, our to-dos query is now invalid because we have just mutated the data. For that purpose, React Query has an invalidate queries method that lets you mark queries as stale and refetch them too. A side note worth mentioning is that React Query supports partial matching by the query key, so you can match based on the prefix, or you can get really specific and match only an exact query key. So now that we covered the key concepts, I want to go through some more terminology in detail. Up to now, I've been using the terms caching and stale quite a bit, and you might be confused about what this all means. Let's clarify these terms. First, I want to remind you of something we touched upon earlier. React Query manages caching for you based on query keys. This is used to uniquely identify data. So now let's talk about staleTime. StaleTime refers to the duration until a query transitions from fresh to stale. For fresh data will always be read from the cache only, no network request will happen. On the other hand, for stale data, if the query becomes stale, by default that's instantly, you will still get data from the cache, but a background refetch can happen under certain conditions to make that data up to date. So let's expand on these certain conditions. Stale queries are refetched automatically in the background when the following happens. New instances of the query mount, so like a new React component using that query. If the window is refocused, if the network is reconnected, or if the query is optionally configured with a refetch interval. So we can see that React Query handles a lot of refetching logic for us. CacheTime, on the other hand, is the duration until inactive queries will be completely removed from the cache. This defaults to 5 minutes, so queries transition to the inactive state as soon as there are no observers registered, so when all components which use that query have unmounted. Now that we went through a whole bunch of theory, let's actually practice by building an application that uses React Query. If that interests you, stay tuned for the next video.